Salam sejahtera kepada Dr. Syahidah dan rakan-rakan sekalian. So in this video, I will present the Tugasan of Aljabar linear. And in this video, the questions are taken from Tugasan kumpulan 7. Okay, so now let's get started. So this is our first question. Discuss the existence of inverse matrix for a 2 times 2 diagonal matrix M as shown for any real numbers A and D. Then apply your answer to n times n diagonal matrix. So there are two parts in this question. The first part is discuss whether the diagonal matrix M has inverse or not. Then we apply this answer to a n times n diagonal matrix. So now we do the first part first. So here's a theorem for 2 times 2 matrix. So let's say we have a 2 times 2 matrix A like this. And this matrix is invertible if and only if AD minus BC not equals to 0, in which case the inverse is given by the formula as shown. So that means for a 2 times 2 matrix has inverse, AD minus BC, or we call determinant, cannot be 0. So same for M. So this is the formula in the theorem. So now we substitute all the values in the matrix M into this formula, and at the end we get A not equals to 0 and D not equals to 0. So that means matrix M can be inverted if and only if the values of A and D are not equal to 0, because the values of B and C in the matrix M are 0. So now we assume that M inverse exists. So how to get M inverse? We can use theorem just now to get M inverse, and this is what we found. But we haven't verified that this matrix is the inverse of M. So what do? We have to show that M multiplied with M inverse and M inverse multiplied with M will get identity matrix. So these are the steps, and at the end we get identity matrices for both the equations. So we have proved that this matrix is the inverse of M. So that's all for the first part. So now we go to the second part. So let's say we have a n times n diagonal matrix like this. And if all the main diagonal entries of this matrix are not equal to 0, that means A11, A22 until ANN are not equal to 0, then this matrix is invertible, or we call has inverse, and the inverse matrix is like this. And notice that this inverse matrix is similar with M inverse we had get in the first part of the question. Okay, so that's all for question 1. So now let's go to question 2. By using the properties of determinant, calculate the value for the determinant of this matrix. So how to get our answer? So let's see the lemma 2.1 in our nota. So if A is an n times n triangular matrix, no matter it's upper triangular, lower triangular, or diagonal, then determinant of A is the product of the entries on the main diagonal of the matrix. So we will apply lemma 2.1 on this matrix to get our answer. But before we apply lemma 2.1 on this matrix, we have to change this matrix to a triangular matrix. So how to change it? We can use lemma 2.5 in our nota. So suppose matrix A of size n times n, if a new matrix B obtained as follows. A multiple of one row or one column of A is added to another, then determinant of B is equals to determinant of A. So that means these two operations will not change the value of determinants. So now we apply lemma 2.5 on this matrix to change it to a triangular matrix, and at the end we get a lower triangular matrix. So now we can apply lemma 2.1 and we get the answer is 0. We can also check our answer using cofactor expansion. So using cofactor expansion along row 1, we still get the answer is 0. So we can conclude that the determinant of this matrix is equal to 0. So that's all for the question 2, and we comes to the end of the video. Thank you.